Hello, this is Todor, the author of the world's first university course in artificial general intelligence. In this video, I will make a short overview and I will comment INSAIT series on trends in AI and computing. It was a set of lectures in the spring of 2023. Very renowned speakers. My favorite from them is Michael Bronstein, about geometric deep learning. If you are a fan of the programming language Scala, you may like also Martin Odersky. So let's start with the lecture which was the less interesting for me. Robbing the bank with automated reasoning. Automated reasoning is nice, but this is very specific about protocols for authorization. Like it reminds me the UML diagrams from the textbooks about automatic teller machines. They used to have such interaction diagrams. Unless you are interested in fintech, I would skip the lecture on Scala. If you are interested in functional programming and Scala in particular, for developing big systems with a lot of parallelism, so this is useful. Michael Bronstein and geometric deep learning. This is one of the best in this series. Very fundamental knowledge and fundamental ideas which allow generalization and give a lot of insight. However, I suggest you to read the book, not just to watch the lecture or the slides. The slides may be too cryptic if you don't read the book, or if this is something new for you. The book is free. It was published in 2021. I suggest also to check one very nice course. It's from 2019, Shape Analysis or Geometric Data Processing Group. Sample lecture. Applications of the Basin. It may give you a lot of geometric and topological intuition. Let's see the book. Also check the work of Petr Veličković. So this is a lecture on scaling. This is also a good one. But it is again kind of specific, like the lecture about the protocols. and it would be useful if you have big compute with many nodes, with hundreds of nodes. Two other topics which are from my favorites as ideas, directions, not the specific content. The content is maybe a bit superficial. AI will program itself, synthesis learning and beyond. It's interesting that 10 years ago, when I was discussing with programmers that it's why computers are not programming themselves yet, they were laughing at me. And I wrote about that even in 2003 in one essay. But this is another story. So let's see what's the gist of this lecture. This one is one of the key ideas. That reminds me of one article called "Creativity is an Imitation of Algorithms" from 2003 in the Sacred Computer magazine. And this is what the generative models do. But what I didn't like about this lecture is key idea. It's just like you have components, you find a way to combine them, like combinatorial exploration. This is the Dream coder, which tries different combinations and produce structures which generate the images from the given dataset, target images. But something which to me is not good is the simplicity of their language. Yeah, maybe they have another vision about this. Maybe their opinion is that it should be so simple, so it could be easy to express with the simplest possible code, but it implies lack of deep semantics. At least my own way of thinking about that stuff is with more complex structures and more complex concepts. There is one thought of Arthur Schopenhauer that says, where calculation begins, comprehension ceases. Check it in Artificial Mind book. And also this particular topic, the Dream coder, reminds me of also this thing is related, but I'll talk about it in another occasion. These are some symbols in the language of thought called Zrim. Zrim is a Bulgarian word which is approximately like visible, something that can be seen visually. It's making the thought process visual and expressive. This lecture is good. Neurosymbolic programming. That's a right direction of building hybrids. However, I personally disagree with the sharp distinction between symbolic and connectionist. Neural networks are also symbolic. The dichotomy is a new pose problem, in my opinion. So this is a right, interpretable, verifiable, structured domain, data efficient, blah blah blah. But there is one key mistake in the conceptualization of the symbolic. It is that what is essential and what is powerful, what could be powerful, is being conceptual, not just symbolic. It's the concepts which are powerful, not the symbols. Symbols are like characters. In Bulgarian, symbol is the word for a character, like A, B, C, and as I see in the literature, the usual discussors, if I can call them like that, use symbolic namely for addressing simple mathematical formulas and this is another error in my opinion, in the researchers who are too deep in the mathematics. They're like obsessed with very simple formulas like these ones. Minimize this, maximize this, multiply this, sum this, mean loss. I suggest one article of mine called Ultimate AI and comparison with the ideas of cognitive algorithm, etc. Learning strategy, so you have domain specific language or some code that represents the output, and you search representations that map the transformations to the domain specific language. Program enumeration, this is a good one. You actually don't need so much neural stuff, but this is another topic which again I will skip for now. Another good idea is penalizing complex programs. I don't remember it. Was it in this lecture or in another lecture about automatic programming in this course? And this one. This is again on code generation. The presenter is from tab 9. Coding assistant. So this lecture on automatic programming or code generation is more large language model based, unlike the earlier program synthesis one. Large language models, they're likely sequence models, and that's why they are so general. Here they display the emergent abilities, the so-called emergent abilities. There are discussions on why they appear and what they represent? In my opinion, they represent something like a cycle, or just hitting enough times particular correlations, or building enough depth in the search, which finds the closure of the circle. Like if A, then B, then C, then G, some correlations, and at last it returns back to some earlier item. This is abstract. I don't map it to something particular, but like the search space is so big and the search is so inefficient that the target, it was already there, but you have to sift through a huge amount of garbage before you reach to the goal. There were some discussions in Machine Learning Street Talk about the lottery ticket. It's another idea, but if you find a lottery ticket of weights early in the training, you can find a better model earlier. Here they give examples of bad results from large language models for reasoning. Well, in general, there are much simpler ways to reason, in my opinion. This is like shooting flies with nuclear weapons, but that's again another topic. Chain of thought, that's good, but it's again in not structured. There are better ways for this. Former, this is also a good idea. Maybe the most interesting part of this lecture is this language thinking like transformers, RASP, restricted access sequence processing, applying manipulations like if you were a transformer. An interesting mind gymnastics, but it looks like a toy if you are supposed to do it manually.